Hello my dear students, welcome to video number 149 of my channel MALACHEMPHILIC. This is the second video of the course Inorganic Semi-Micro Analysis, and here I am going to discuss few preliminary examination of the salt. So let's see. See, this slide already I have shown you earlier what are the topics will be covered in this course. Among these, this laboratory safety and precaution already it is done. Apparatus used in semi-micro analysis also I have done it in my earlier video, and today I am going to discuss the preliminary examination of the salt. Three preliminary examination today we will discuss. So let's start. First one, study of the color of the salt. Some transition metal element salts are colored. So by seeing the color, you can guess, you can have some guess. Say for example, copper is blue color, then nickel is greenish color, ferric is brown color. So roughly you can guess about the salt. So here I have given this different color of the transition metal cations. You can go through it. Now, second one is dry test tube heating. Here, you have to take the salt in a dry test tube and you have to heat it strongly in the flame and observe the changes. This dry test tube heating observations we can categorize into four categories. First one is this colored residue due to formation of the oxide. Due to strong heating, some metal oxides sometimes formed, and these oxides will have the different color than that of the salt. So here this one, that is this zinc, that is which is yellow when hot and white when cold. This is very commonly found. And then this one, this is ferric salt, which is brown in color. Then ferrous, which is greenish, light green, but when hot it is brown color because ferrous is oxidized to ferric. Now, second category is colored residue due to loss of water of crystallization. Most common is this copper sulfate salt. We know that copper sulfate has 5 water of crystallization and it is blue in color. But when you are heating the salt, this water of crystallization is lost and anhydrous copper sulfate is white in color. So, here the color change is white. That is blue to white. It is the color change. Like that, some other metal salt also, this anhydrous form will have the different color. Now coming to the third category, that is a gas or vapor is evolved. If you get the dark brown or reddish brown fumes of nitrogen dioxide, that may be the ammonium nitrate or the nitrate, other nitrate in presence of ammonium salt. Otherwise, if you get the smell of ammonia, then also it may be the ammonium salt. If you get the smell of burning sulfur, it may be the sulfite salt or certain sulfate. If you get the smell of rotten eggs, then it is sulfides. If the greenish yellow pungent smelling gas is evolved, that means the chlorine gas, then it may be the unstable chlorides or chlorides in presence of oxidizing agent. So chloride in presence of oxidizing agents converted to chlorine. So you'll get this greenish yellow color gas of chlorine. If you like that, if you get the brown vapors, then bromide in presence of oxidizing agent. If you get the violet vapors, then certain iodides. Now the fourth is the sublimate formation. Sublimate formation most important in case of ammonium halides and aluminium chloride. Ammonium halides, it gives this type of, even aluminium chloride, this type of white sublimate. Okay. Then blue-black sublimate, if you find it, then it is maybe iodide salt. If the substance swells, if the size increases, it forms some ball type thing, glassy ball things, then it is borax or phosphate. And if the decrepitation takes place, decrepitation means when it is heating, burning, some cracking sounds will be developed. Say for example, it is most important for this lead nitrate. When you are heating lead nitrate, then nitrogen dioxide gas, that is brown vapors, oxygen gas is formed, lead oxide is formed, and it burns with the cracking sound, that is decrepitation. Now, third one is the flame test. Now, before going to the flame test, let me discuss a little bit about the flame. In the burner, when you observe the flame, this outer part, the outer part will be bluish in color, or sometimes it may be invisible also. Here the fuel burn in presence of sufficient oxygen. So here this part, it acts just like a oxidizing agent. That means if you heat the salt in this part, the substance may get oxidized. Whereas this inner part, here the fuel means liquid petroleum gas, which is nothing but the hydrocarbon. This fuel burns in presence of insufficient oxygen, so it is not the complete combustion. So some carbon particles will be present, and this is the reducing flame. Because carbon particles are there, here if you keep the substance, it may get reduced. This outer part, which is the oxidizing flame, that is known as the non-luminous flame, and this inner flame, which is the reducing flame where carbon particles are there, that is luminous flame. Now we'll see the reason for this flame test. Before that, let me tell you, this flame test is given by S block salt. That means salt of alkali metal and alkaline earth metal. Okay. Now, before going to the reason, let me explain the procedure for the flame test. In the flame test, what you have to do, first you have to take the platinum wire and you have to make a loop like this at the tip of the platinum wire. Then you have to dip the loop at the paste of the salt in concentrated hydrochloric acid. Then you have to hold it in the flame and observe the color of the flame. This is the procedure. Now, when you are holding these chlorides of the salt in the flame, why you are getting the colors? The reason is like that some of the chlorides, certain metal chlorides, they easily ionized. Okay. And that is the thermal ionization, and the ions get excited by promoting the electrons to the higher energy level. And when this electrons comes back to the ground state, that means during de-excitation process, then that energy is emitted in the form of radiation, which falls in the visible region. So you get the coloration of the flame. Now, in the flame test, always we should take the concentrated hydrochloric acid because the chlorides are more volatile. So it imparts the characteristics color to the flame more readily. That's why concentrated hydrochloric acid is taken. That means paste you have to make it with concentrated hydrochloric acid. Now we'll see the different flame coloration. That is flame coloration of different S block element salt. See, first one, this is sodium flame. What is the color? It is golden yellow but invisible through blue glass. Now let me tell you about this blue glass. Cobalt blue glass we use when there is a mixture of salt. That means mixture of cations are there, which both may impart the color in the flame. Okay. Say for example, sodium and potassium. If both are present, then you cannot identify the color clearly. In that case, when this cobalt blue glass is used, it absorbs the sodium color, sodium flame, and it transmits the color of the potassium flame. Okay. Similarly, now you see the potassium flame. Potassium flame, it is light violet but intense violet, red or crimson to the blue glass. Now coming to the calcium flame, which is very commonly seen in the laboratory. It is the transient brick red colored flame. Okay, but light green through blue glass. Then barium flame, it is the persistent green, or it is known as the apple green colored flame. So, but bluish green through the blue glass. Then your strontium flame. Strontium flame is persistent crimson red colored flame. Okay, but to that blue glass it is purple. Now coming to this copper flame. Though copper is not S block elements, but copper will give the flame coloration, and here the color is greenish blue, or more precisely you can tell greenish color with center blue. So bluish green or greenish with the blue center. Now Other than this rubidium gives the red-violet color flame, cesium gives blue color flame, lithium gives crimson red flame, and boric acid also gives this green colored flame. Now, the question is that though we know that alkali and alkaline earth metal salt, they gives the flame coloration, but beryllium and magnesium, they also S block element, so beryllium and magnesium, they don't give the flame coloration. Why? Actually, what happened during this ionization and the excitation process, they absorb more energy, and when the electrons come back to the original state or ground state, during the de-excitation process, that radiation is not falling under visible region. So, we don't get the coloration. Now coming to the borax bead test. So, Borax Bead test is given by transition metal cation. So, if your salt is colored, then only you should perform Borax Bead test. Otherwise, if the salt is colorless, no need to perform Borax Bead test. Now, here. So, what is borax? Borax is this one, that is Na2B4O7 and 10 water of crystallization. Okay. When it is heated, it becomes dehydrated. That is Na2B4O7 plus 10 water molecule. Okay. Now, this anhydrous borax, that is Na2B4O7, on strong heating, it forms the sodium metaborate and anhydride of the boric acid B2O3. This mixture forms the glassy bead, that is borax bead. Okay. Now, this anhydride of this boric acid, it is less volatile. It can releases the more volatile anhydride of the other acid from the salt. Say for example, if I take copper sulfate, then copper sulfate plus this B2O3, then it will form this copper metaborate. This is cupric metaborate plus this anhydride of this acid. Sulfuric acid anhydride is sulfur trioxide. Okay. And these metaborates of the metal of the cations are colored. Transition metal cations are colored. Say this one is green when hot, and blue when cold. When cold, in 1 minute. In oxidizing flame. Oxidizing flame. Okay. So this metaborate has different color in the hot condition and also in the blue condition. Hot condition and also in the cold condition. So this metaborate imparts the color of the flame. Now, in reducing flame, what happened? See, in reducing flame means the inner part where carbon particles are there, where reduction takes place. So, here first what happened? This copper metaborate, it is cupric metaborate, it is reduced by carbon and it will form the cuprous metaborate after reduction, and then plus carbon monoxide and your this one B2O3. Okay, and this one, this is cuprous metaborate, it is colorless. So when you are holding this flame, in this reducing flame, then you'll not get any color. And in some cases, even here itself, what happened? This cuprous one, that is cuprous metaborate, once again it is reduced in the reducing flame, that is the inner flame. And then here if we balance it, it will be like this. Then what we'll get? So here also we'll take 2. So what we'll get the metallic copper. And all of you know the color of the metallic copper. That means that reddish color. Okay, that is what we can say, it is reddish brown. Reddish brown. Okay. So in the borax bead test, first this bead is formed after heating this borax, which is the combination of sodium metaborate and boric anhydride. Then with boric anhydride and the salts of the transition metal, it forms the different metaborate of this cation, which are colored. And it gives different color in hot and cold condition, as well as oxidizing and reducing flame. Now, let me explain the procedure. Here what you have to do in this process, first of all, you have to clean the platinum ware by heating in the oxidizing flame, so that if any other salt was adhered on it, it will give the coloration. First of all, you have to heat it and make it completely clear. Then you have to dip the this loop of the platinum wire into the borax, and then you have to heat in the flame to make the borax bead. So after strong heating, you will get this type of glassy bead. Then this bead, you have to dip it into the unknown salt and again heat it in the flame. Then gently you have to heat it, and you have to observe the color of the flame in the oxidizing flame as well as in the reducing flame. Now these are the table of this color of the borax bead in oxidizing flame and reducing flame of different transition metal cation. Okay. Now coming to the microcosmic salt bead test or phosphate bead test. Okay. What is microcosmic salt? Microcosmic salt is sodium, I'll write, microcosmic salt. It is nothing but sodium, ammonium, hydrogen, phosphate. This is microcosmic salt with 4 water of crystallization. Okay. Now, its test is just like borax bead test. This microcosmic salt, you have to hold it, take it in the platinum loop and hold it in the flame. That bead will form. That bead, you have to dip it in the salt and again you have to heat it. You will get the coloration, and the coloration also same as that of the borax bead test. That means the different cation give the same coloration in the microcosmic salt bead test and the borax bead test, right? But what is happening here? When you are heating this salt, then this sodium, ammonium, hydrogen, phosphate, this is hydrated salt, 4 water of crystallization. So 4H2O, it is getting dehydrated and anhydrous salt is formed. Anhydrous salt is sodium, ammonium, hydrogen, phosphate plus water, plus this water. Right? Now, what happened? This anhydrous salt, when it is heated, NaNH4, hydrogen phosphate, when it is heated, it forms the sodium metaphosphate. So NaPO3 and plus this ammonia gas is evolved and water vapor is evolved. right? So this is nothing but this is your sodium metaphosphate. Sodium metaphosphate, right? Now what happened? This sodium metaphosphate can dissolve some of the metal oxides and form the orthophosphate. Say for example, this I'll take this one, the cobalt oxide plus this sodium metaphosphate NaPO3. Then what it forms? It forms the orthophosphate. Say sodium cobalt PO4. This orthophosphate, here it is blue in color. So here these oxides of the metal reacts with this sodium metaphosphate, giving the orthophosphate, and these orthophosphates are the colored bead. Okay. Now what happened? This is in the oxidizing, this is blue color flame, that is in the oxidizing flame. Now, just like borax bead test, in that reducing flame, what may happen? This orthophosphate may reduce and then the color will be different. Say for example, if I take the same earlier one, that is copper salt, so it will be the copper sodium PO4, copper orthophosphate, and then it is reduced by carbon, and what it will form? It will form the metallic copper, and metallic copper, you know the color, red or reddish brown, you can tell. And then once again this sodium metaphosphate will form and carbon will be oxidized to carbon monoxide. So these in oxidizing flame you are getting the color due to this what? Orthophosphate of the cations. Okay, and when it is reduced, then you can get the color due to different other formation. Say for copper salt, it is the metallic copper, you'll get the red color. So coloration procedure same as that of your borax bead test. So we have come to the end. Hope you have understood. And the next video, I'll discuss the remaining preliminary tests like charcoal cavity test and the fusion test for chromium and manganese. So, thank you.